Today we are going to start a new chapter in organic chemistry, that is amines. And first we have the structure and nomenclature of amines. What about the structure of amines, or what is amine functional group? Amines can be considered as derivatives of ammonia. How we can consider amines as derivatives of ammonia? Let us see. We know the formula of ammonia is NH3, and if I am replacing one hydrogen atom of ammonia by an alkyl or aryl group, what will happen? So if I am replacing one hydrogen from NH3, it will become NH2. And if I am replacing by an alkyl group, we know that alkyl groups are generally represented as capital R group. So what we are getting here is RNH2. So this class of compounds are known as amines. So amines functional group is NH2 group. Now here, instead of an alkyl group, if I am replacing one hydrogen by an aryl group, we will be getting it as benzene ring NH2. So benzene ring is an example for an aromatic system. Now in the second case, if I am replacing two hydrogen atoms of ammonia by two alkyl groups, we will be getting it as NH3 will become NH, and I am replacing by two alkyl groups, so it will become R2NH. This is another class of amines. Now instead of two alkyl groups, we can replace by two aryl group also, or we can replace one hydrogen by alkyl group and one hydrogen by an aryl group. For example, if I am replacing two hydrogen atoms, it will become NH, and I am replacing one hydrogen by an aryl group, for example benzene ring, and one hydrogen atom I am replacing by an alkyl group. So this is also another class of amines. Now in the third case, if I am replacing all the three hydrogen atoms on ammonia by three alkyl groups. So if I am replacing all the three hydrogen atoms, NH3 will become N, and I will be replacing by three alkyl groups, so it will become R3N. So these are also called as amines, but another classification of amines. Now here also, instead of three alkyl group, we can replace by two alkyl group and one aryl group, or two aryl group and one alkyl group, etc., etc. For example, nitrogen atom, I am replacing one hydrogen by one aryl group, that is benzene ring, and by two alkyl group. So these are the different classes of amines. Then what about the classification of amines? How we can classify amines as? Classification of amines. Amines are classified as primary, secondary and tertiary amines. Now how we can define these primary amines, secondary amines and tertiary amines? See the first case, RNH2, it is an example for a primary amine, or benzene ring containing NH2, that is another example for a primary amine. So how we can define primary amine? If it is NH2, we can say that it is a primary amine. So the definition for a primary amine is nitrogen atom containing two replaceable hydrogen atoms or what we can say is, if the nitrogen atom, if it is attached to one carbon atom only, it can be considered as a primary amine. So we can check whether the given amine is a primary, secondary or tertiary amine by checking or by looking at the nitrogen atom. If it is NH2, we can say that it is a primary amine, or check the number of carbon atoms to which this nitrogen atom is attached. For example, CH3NH2. Check whether it is a primary amine, secondary amine or tertiary amine. Look at the nitrogen atom. If it is a primary amine, we can say that, if it is NH2, we can say that it is a primary amine because nitrogen has two replaceable hydrogen atoms. Or we can check the number of carbon atoms to which the nitrogen atom is attached. So here the nitrogen atom is attached to only one carbon, so it is a primary amine. Now the second example is benzene ring containing NH2. So here also look at the nitrogen atom. Since it has two replaceable hydrogen atoms, since it is NH2, we can say that it is a primary amine, or we can check the number of carbon atoms it is attached to. So here the nitrogen is attached to only this carbon, only one carbon, so it is a primary amine. So how we can define a primary amine is, if it is NH2, it is a primary amine. Or we can say that nitrogen with two replaceable hydrogen atoms. Or what we can say is, if the nitrogen is attached to only one carbon, it is a primary amine. Now the next classification of amine is secondary amines. For example, R2NH, it is a secondary amine. A general representation of secondary amine is R2NH. So from this, how we can define a secondary amine? Nitrogen with only one replaceable hydrogen atom. Or in terms of number of carbon atoms, how we can explain? What do you mean by R2NH? If we are expanding the structure, R2NH means two alkyl groups are attached to the same nitrogen atom. So in terms of number of carbon atoms it is attached, how we can define a secondary amine? If nitrogen is attached to two carbon atoms, it will be a secondary amine. Or simply what we can say is, if it is NH, it will be a secondary amine. For example, CH3NHCH3. Here from NH itself it is clear that it is a secondary amine with only one replaceable hydrogen atoms. Or what we can say is, this nitrogen atom is attached to two other carbon atoms, so it is a secondary amine. Both the definitions are correct. Another example is CH3NHC2H5. Here also from NH itself it is clear that the nitrogen has only one replaceable hydrogen atom, so it is a secondary amine. Or the nitrogen atom is attached to two other carbon atoms. Don't say that here there is two carbon atoms and here there is one carbon atom, three atoms. No. C2H5, we know that it is CH2CH3. So here nitrogen is attached to only one carbon atom, only one carbon here and one carbon here. So nitrogen is attached to two other carbon atoms, so it is a secondary amine. So this is about the definition of secondary amines containing one replaceable hydrogen or nitrogen attached to two other carbon atoms. Now moving to the third classification as tertiary amines. The general representation is R3N. From the general representation itself it is clear. R3N, if we are expanding the structure, it will be the three alkyl groups attached to the same nitrogen atoms. So how we can define a tertiary amine is nitrogen without any replaceable hydrogen. Nitrogen atom without any replaceable hydrogen, or based on the number of carbon atoms attached, how we can define nitrogen atom attached to 3 carbon atoms. So this is about the definition for a tertiary amine. Once we see that it is N only, nitrogen atom without any replaceable hydrogen, it will be a tertiary amine. Or look at the number of carbon atoms attached. If it is attached to 3 other carbon atoms, it will be a tertiary amine. So this is about the classification of amines as primary, secondary and tertiary amines. So how we can conclude is, if it is NH2, once you look at the structure, given structure or the given molecule, if it is NH2, we can write it as primary. If it is NH, it will be secondary. If it is N, if it is NH2, only 1 free valency. If it is NH, there will be 2 free valencies because nitrogen valency is 3. So here only 1 hydrogen, so 2 remaining valencies. Here there is nitrogen only, no other hydrogen or nitrogen, so we have to draw 3 free valencies. If it is N only, it will be a tertiary amines. This is the easy way to identify, just like alcohols we have studied. If it is CH2OH primary, CHOH secondary. If it is COH without any hydrogen, it will be tertiary. So this is the easy way to identify whether it is a primary, whether the given compound is a primary, secondary or tertiary amines. Now in the textbook, exercise in-text question 13.1, there is a question to classify the following compounds as primary, secondary or tertiary. So the first compound given is how we can classify this as a primary, secondary or tertiary amine. Look at the nitrogen atom. If it is NH2, yes, we can write it as it is a primary amine. Second question is, this is the second question. How we can classify this as primary, secondary or tertiary? Look at nitrogen atom only. It is N only, there is no other replaceable hydrogen atom, no nitrogen on this hydrogen. If it is N only, we can say that it is a tertiary amine. Now the third question is, how we can classify this? Look at the nitrogen atom. Here it is. Yes, NH2. So we can write it as a primary amine with 2 replaceable hydrogen atoms. And the last question is, C2H5 twice NH. Again, look at the nitrogen atom. Here it is NH. So with only 1 replaceable hydrogen atom, or if it is NH, we can write it as secondary amine. So this is about the classification of amines. Now in the in-text, there is one more question, that is 13.2. To write the isomers of the compound, write all the isomers of the compound with molecular formula C4H11N. This is the question, to write all the structural isomers of the compound with molecular formula C4H11N. How we can write the structural isomers? So whenever we study the functional groups, such type of questions are usual questions. So how we can write the structures of amines? So when we write the structures or structural isomers of amines, first we have to remember is there is primary amines, secondary amines and tertiary amines. So here first possibility is we will write primary amines. So here we have 4 carbon atoms. So first possibility is we will arrange all the 4 carbon atoms in a straight chain, 1, 2, 3, 4, and we will write nitrogen on first carbon. So if we are writing nitrogen on first carbon, it will be NH2. Now add remaining hydrogen, CH2, H2, H2, CH3, and check the formula C4. Here the formula we are getting it as C4H11N. Now second possibility is again 4 carbon atom straight chain, and I am changing the position of amino group. I am writing or I am attaching NH2 group on the second carbon atom and give the hydrogen atoms CH3, CH2, CH. Again we are getting the same formula as C4H11N. The same molecular formula but different structures are known as structural isomers, and we are getting another isomer. Now there is no other possibility on the straight chain carbon atoms. If I am attaching this NH2 group on the third carbon, it will be same as on second carbon, and if I am attaching the NH2 group on the fourth carbon, it will be same as the first carbon itself. Now the next possibility is 3 carbon atoms straight chain and 1 carbon atom is coming as branch. So how we can attach nitrogen is, and I am giving NH2 on 1 carbon, CH3, CH3, CH, CH2, again getting the same formula as C4H11N. This is another isomer of this compound. Now the fourth possibility is the same 3 carbon straight chain and 1 carbon is coming as branch. I am attaching NH2 group on the second carbon atom. So CH3, CH3, getting the same formula as C4H11N, but another isomer, another structure. Now the fifth possibility is I am writing the structures of secondary amines. Secondary amines means it will be NH and nitrogen will be attached to 2 other carbon atoms. So here we have total 4 carbon atoms. So how we can arrange the 4 carbon atoms on either side of nitrogen? Yes, we can write or we can give 1 carbon on one side and 3 carbon on another side. So how it will be? CH3, CH2, CH2, CH3. Okay. Again the molecular formula will be same as C4H11N. Now the sixth possibility is again I am writing a secondary amine. So nitrogen will be attached to 2 other carbon atoms. So how we can, what is the next possibility to arrange carbon atoms on either side of nitrogen? Total we have 4 carbon atoms. So in the first case we have given 1 carbon on one side and 3 carbon atoms on another side. Next possibility is 2 carbon one side and 2 carbon another side. So what will be getting it as CH3, CH2, CH2, CH3. Again the molecular formula saying that is C4H11N. Another structural isomer of this compound with molecular formula C4H11N. Now the next possibility is 7th isomer is from the 5th isomer, that is here it is CH3NH, and instead of writing all the 3 carbon atoms straight chain, 1 carbon atom I am going to give as a branch here. So it will be CH, CH3, CH3. Again, molecular formula is same, but the structural formula is different, and such class of compounds are known as structural isomers. Now the last possibility is, so primary amines possibility over, secondary amines possibility over. Now we will see any tertiary amines possible with this structure. What do you mean by tertiary amines? Nitrogen attached to 3 other carbon atoms. So total we have 4 carbon atoms here. So 1 carbon here, 1 carbon here, and the only possibility is give 2 carbon atoms on any one side. So it will be CH3, CH3, CH2, CH3. Again, the molecular formula same, but structural formula is different. So these are the different structural isomers possible with the molecular formula C4H11N. Total how many isomers are possible here? 8 isomers are possible. Among this, how many are primary amines? The first one, it is NH2, so it is a primary amine. Second one is also NH2, so that is also a primary amine. Third one is also NH2, it is a primary amine. Fourth one also NH2, again it is a primary amine. But fifth one, it is NH, so it is a secondary amine. Sixth one also NH, so it is a secondary amine. And the seventh one is also NH, so it is a secondary amine. And the last one is, the 8th isomer is nitrogen atom, no replaceable hydrogen, so it is a tertiary amine. So these are the pattern of questions coming for the exam. So question will be coming to write the isomers of a compound with so and so molecular formula. So find out the possibility with primary amines, secondary amines and tertiary amines. Now, next we have the nomenclature of amines, and as we know, we have common system of naming and IUPAC system of naming. In common system of naming, amines are named as alkyl amines, and according to IUPAC system, they are named as alkanamines. How we are getting alkanamine name is by replacing E of the last E of alkane will be replaced by amines. So remember, in IUPAC system we are naming amines as alkanamines, but in common system we are naming as alkyl amines. Now question to write the IUPAC names of different compounds, and we will see the common names of few compounds also. So see the first one, it is CH3NH2. The rule is same for all the functional groups. Select the longest carbon chain, write the word root, then number the carbon atoms in such a way that the functional group should get the lowest possible number. So here there is only 1 carbon, so you need to number actually 1 carbon means the word root will be meth. It is singly bonded, so methane. So the last E will be replaced by amine. So it is methanamine or methan-1-amine. So if it is number 1, no need to write. So the common name will be here, the alkyl group is CH3, so it will be methylamine. Now the second compound, so here functional group attached to carbon should get the lowest possible number. So here we should give number 1, 2. So it is 2 carbon means it is eth. They are singly bonded, so ethan, 1 amine or same as ethanamine. or ethanamine, or the common name will be ethyl amine. Now in the third compound, this is the longest or the straight chain. Now we have to give the number so that the NH2 attached to carbon should get the lowest possible number. So number 1, 2, 3. So 3 carbon means the word root will be prop. They are singly bonded, so propan. NH2 is on second carbon, so it is propan 2 amine. Now in the third compound, it is a secondary amine, and in the case of secondary and tertiary amines, there will be more than one alkyl group surrounding the nitrogen atom. So select the chain with low or more number of carbon atoms as the parent chain. So here on one side there is methyl group, and on another side it is CH2CH3. So where there is more number of carbon, select that as the parent chain. So here the parent chain is CH2CH3. So here only we have to give number. So it is 1, 2, because NH attached to carbon should get number 1. Then how should we name this methyl group? It is actually from NH2, one more hydrogen is replaced by methyl group. Okay, from NH2 group, one more hydrogen is replaced by methyl group, or what we can say is one hydrogen is substituted by methyl group. So how to write the name is, it is 2 carbon atoms, so it is eth, singly bonded, so ethan, 1 amine or ethanamine, and this we have to write as prefix. So how to write it as is capital N hyphen N methyl. So the name is N methyl ethanamine. Next one, it is a tertiary amine. Nitrogen is surrounded by 3 different alkyl groups, but all the 3 alkyl groups are same. So select any one as the parent chain. So this will be number 1. And here on nitrogen we have 2 methyl group as substituent. So how to name it as N dimethyl. Okay, it is N, comma N, D should be capital, dimethyl. Then 1 carbon means it is meth, so methanamine. So the name is NN dimethyl methanamine. The next one is again a tertiary amine. So on one side we have 2 carbon atoms, another side we have 2 carbon atoms, but in the other side we have 4 carbon atoms. So select this one as the parent chain and give the number. So 1, 2, 3, 4. The other 2 will go as substituent. So here it will be NN diethyl. NN diethyl. Then 4 carbon means bute, singly bonded means butan, 1 amine or butanamine. In the next question, we have 2 functional groups, that is, one is a double bond and one is NH2 group, and we know that according to priority rule, double bond and triple bond are getting lowest priority. So when we number this chain, NH2 attached to carbon should get the lowest possible number. So it is 3 carbon means prop. There is a double bond and the position is 2, so it is prop 2 ene. NH2 is on first carbon, so ene 1 amine or prop 2 enamine. Okay. Now in the next question it is given as NH2, CH2 6 times NH2. This we can write it as NH2, CH2, 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 So when we give the number, it will be 1, 2, 3, 4, 5, 6. 6 means hex. They are singly bonded, so AN, hexane. 1,6-diamine. So whenever there is di and tri, we have to retain the last E. So it is hexane 1,6-diamine. Now the next question is benzene ring containing NH2. Here the name is when a functional group is attached to ring system, write how to do the IUPAC name, write the name of the ring, complete name of the ring, then write the functional group name. So here it is, the ring is benzene amine, or it is benzenamine, or the common name is aniline. Aniline name is accepted by IUPAC system also. So in IUPAC also we will be using the name aniline. So the IUPAC name of this compound is benzenamine or aniline. Now the next one is benzene ring containing one NH2 group and one methyl group. So according to priority, number 1 here, 2 here. So it can name as 2-methyl aniline or 2-methyl benzenamine. Now aniline containing methyl group, there is a common name called toluidine. Toluidine is a very common term we will be using in the coming reactions. So aniline with methyl group as another branch, the common name of the compound is toluidine. So if methyl group is coming at the ortho position, it will be named as orthotoluidine. So the common name of this compound is orthotoluidine. The next one, benzene ring containing NH2 and one bromine. We know that bromine halogens are having least priority. They are not at all coming in the priority order. So 1, 2, 3, 4. So it is 4-bromo-aniline, or we can name it as 4-bromo-benzenamine. The next question here, nitrogen has 2 branches, that is 2-methyl group. So nitrogen is surrounded by 2-methyl group and 1 benzene ring. The one with more number of carbon atoms, we have to take it as parent. So here take this as parent. So benzene ring containing NH2, we can take it as aniline as the parent. So the name will be, so these 2 methyl groups will go as substituents. So it is NN dimethyl aniline or benzenamine. The next one is, the name is, it is NH. So here it is N-methyl aniline or benzenamine. Now in the last question, it is given as MBr-C6H4NH2. M, we know that it is abbreviation of meta. So it is meta-bromo C6H4NH2. So C6H4 means we know that benzene ring, this molecular formula is C6H6. So when a branch or when a substituent comes in the benzene ring, it will become C6H5. And when there is 2 substituents are coming, it will become C6H4. And if there is 3 substituents, 1 more hydrogen will be reduced. So from this molecular formula, it is clear that here it is given as C6H4. C6H4 means it is benzene ring with how many branches are there? H6 became H4 means there is 2 branches or 2 substituents. And what about the position of the substituents? It is represented by M. They are at meta positions, means if one branch is here, one branch will be here. And which are the two branches we have? One is bromine and one is NH2. So this is about the structure of this compound. Now how we can name is 1, 2, 3 because bromine with least priority. So the name of this compound is 3-bromoaniline. So this is about how to write the IUPAC name of amines. Okay, aniline is an IUPAC accepted common name. Okay.